So these electrons are accelerated through a potential V, all right, and they gain velocity V for that, which means that potential V, let me write the word here, potential will be given as 6.0 kV, which means we're looking at 6 into 10 to minus 3 V. So width of screen, remember, ys will be equal to 30 divided by 2 to give you 0.15 meters. I'm converting, and x, screen in x direction will be equal to 334 into 10 to minus 2 to give you 0.34 meters. Okay, that means that since the force deflection plates Fs is given as that is 2.6 into 10 to minus 2 meters. I'm using the same units for consistency. You can take that as 0.026 meters. So from there it's quite easy, because again from this scenario we understand that potential energy will be equal to kinetic energy, okay, which means EV will be equal to half of mvx squared. So Vx is the resonance speed of the electron, so we take 2 EV over m and we get the square root. So time spent on the field will be equal to the change in the position of the field. So time spent on the field will be equal to delta xf over Vx. So force in y direction, therefore force in y direction will be equal to E of the electron, which means E of electron will be equal to m_a_y in the acceleration in the y direction. So therefore acceleration in the y direction will be equal to E over m. So substitute the values then, because again from the equation of motion, Vy equals to ay multiplied by tf. So if you substitute these values, we're going to get that as e for the electron over m multiply by delta xf over Vx. Okay, so change in that screen time, therefore ts will be equal to delta xs over Vx. Change in y direction, therefore to call that delta ys will be equal to Vy multiply by delta xs over Vx. Okay, so therefore the solution for electric field eventually E will be equal to delta yxm Vx squared over delta xs E multiplied by delta xf. Okay, so we're having that as 2 into 6 into 10 to the power 3 into 0.15 over, because again 0.34 and 0.026. These draws from 2V multiply by delta ys over delta x, all right, multiply by delta xf for that. This is where it gets us. So this should give you a slight value of around 2.03 into 10 to the power 5 Vm. So the variation from positive E to minus E will be equal to plus 2.03 into 10 to the power 5 to minus 2.03 into 10 to minus 5 of Vm.